We're in chapter 4, so this is section 4.1, and we're talking about congruent polygons. So we talked about polygons before. We just finished our unit. We talked about polygons. We talked about the sides and polygons, angles and polygons, what we could figure out about certain special polygons. But we want to go into a little more detail in this chapter, and then we'll talk more about triangles, because triangles have some nice things that give us some shortcuts. So first, let's remember what we said. What did we mean when we said two shapes were congruent? The same sides, and angles. So that was one way that we talked about things being congruent. We said they were the same. They have the same sides and the same angles. The kind of the everyday way, the working definition that we had was same size and shape. So this was how we think about things that are congruent, same size and same shape. When we talked about transformations, we talked about translations, rotations, reflections, we came up with a little more technical definition of what congruent meant. Does anybody remember that from when we talked about transformations? We said our more technical definition of congruent meant that one shape was a rigid transformation of the other. So we could translate it, we could rotate the shape, we could reflect the shape, and it would fit right on top. It would exactly match the other shape. That's how we could tell if they were congruent, is if one was a rigid transformation of the other. Well, what we're doing in this section, in this chapter, is finding out how do we tell if a shape is one shape is a rigid transformation of another. How can we figure that out? We use congruent polygons turn out to be important in a lot of different areas. Anytime you're comparing shapes, where you want to figure out if two shapes are exactly the same. In science, in architecture, in construction, anytime you're comparing shapes, we need to figure out how we know when polygons are congruent. So that's what we're doing in this section. Well, first thing that we want to talk about is how do we naming polygons? How do we name them? And we've worked with it a little bit before, but what we do, we start at any vertex. We go around clockwise or counterclockwise. And I'm going to just put CW or CCW, clockwise or counterclockwise. And we name the vertices in order. So let's look at a quick example of what this is telling us. So let me grab a pentagon here. And we're going to name this pentagon. So I'm going to label the vertices. So there are my points that are my vertices. To name the polygon, we want to name the polygon. I can start at any vertex. So let me start at L, and I'll go around clockwise. I can call this polygon LM, N-O-K.
What's the symbol?
There isn't a symbol for polygon. We just list the vertices. So if we just have a list of vertices, that tells us we have some kind of polygon. So that's going around clockwise. I could go around counterclockwise. L, K, O, and M. So I've gone around this way, that way. So that's starting at vertex L. Starting at vertex M, I could call this polygon M, N, O, K, L. Or I can go the other way around. M, L, K, O, N. So any of these are names for polygons. I could go to the next vertex, vertex N. I could use vertex O, and I could use vertex K. So I'm not going to write them all out, etc., etc. So I get two different names for each vertex that I go to. I can go clockwise or counterclockwise. If I listed them all out, I would have a total of 10 total names for this polygon. 2 for each vertex. One going clockwise, one going counterclockwise. And I just list the vertices in order. And if I have the name of the polygon, LMNOK, and I want to draw a picture, I just put one of these letters at each vertex in order. I know I have 1, 2, 3, 4, 5 vertices, and I just put these letters on each vertex in order. So I can go from the polygon to the name, or I could go from the name back to the polygon just by labeling each vertex in order. Does that make sense? Any questions? All right. So what's important for figuring out if polygons are congruent is how the parts match up. We need to match up the angles that are the same, and we need to match up the sides that are the same. So what we call that is corresponding polygons. And correspond, the way we're using the word correspond here, just means we want it to match. So corresponding means matching. So we want to match the angles and the sides of the polygon, and we call that corresponding. So we're going to say that polygons correspond, and I'm going to put in parentheses match. Polygons correspond or match if we have two things. We can match congruent sides, and we can match congruent angles. So we say our polygons are corresponding if the sides and the angles match up. So we compare them, we see if they're the same length, we see if they're congruent, and that tells us if our polygons correspond. When they correspond, we can write a congruent statement. And in your book, in your homework, on your quiz or on your test, a question might ask you to write a congruent statement. And a congruent statement is just tells us how the polygon matches up. So, as an example, a congruent statement would say that ABCD is congruent to EFGH. So it just tells us how the parts match up. And we'll look at an example of writing a congruent statement in just a second. But a congruent statement just tells us how they match up. What this congruent statement tells us is that angle A matches with angle E, angle B matches with angle F, angle C matches with angle G, and angle D matches with angle H. So the parts match in order. The order is important. When we write our congruent statement, the order is important. So a congruent statement is just a statement telling what parts of our polygons match up. So let's look at an example of writing a congruent statement. We'll do a couple of examples. We'll start with an easy one. Each of them are actually pretty easy, so it's not too difficult of an idea. So let's start with triangles. So I have a couple of triangles, and we're going to label all the parts on our triangles. And in this chapter, I just want to give you a heads up. It's very important to go by what the pictures tell you, what the diagrams tell you, what the information tells you, not by what the pictures look like. The pictures, if it looks like it's a 90-degree angle, it might not necessarily be a 90-degree angle. If it looks like the angles are the same, it's not necessarily the same. You have to go by what the information tells you. So we'll call this triangle ABC, and this triangle XYZ. And let me mark up this triangle in red. And I'll mark the other one in blue. And remember that the same number of tick marks means that those parts are congruent. And we want to write a congruent statement.
Would this be like what it looked like in the question?
Yes. So we want to write a congruent statement. So I'm going to write triangle, and I'm just going to say ABC, just to make this first one easy, is congruent to what angle does angle A match with on the other triangle? Z. It's congruent to angle Z. What angle does angle B match with? Y. They both have one tick mark, and that just leaves X. So what this tells me, angle A corresponds to angle Z. They both are congruent. Angle B corresponds to angle Y. Angle C corresponds to angle X. They match up. I can also figure out about the sides. Side AB matches with side ZY. Side BC matches with side YX. And side AC matches with side ZX. So this congruent statement tells me how all the parts match up on the triangle. The order is important. And if you were given this congruent statement, I could use this congruent statement to draw my picture. This tells me that A and Z match up, B and Y match up, C and X match up, and so on. So the congruent statement tells us exactly how the shapes match up. Questions on that? What we would say is that angle A corresponds to angle Z, angle B corresponds to angle Y, angle C corresponds to angle X. We're using corresponds just like we would use the word match. All right, let's look at a quadrilateral instead of a triangle. So another example. So here's my quadrilateral, and again, we're going by what the information tells us, not necessarily by what the picture looks like. I'm going to call this ABCD. And I'm going to call this EFGH. And I'm going to mark this one up also. So I'll mark this one in red. And I'll mark the other one in blue. Lots of tick marks here. All right, and we want to write a congruent statement for these polygons. So, what order do you want to go in for this first polygon? What do we want? How do we want to name this polygon? ABCD. Okay, that works for me. And we're going to say is congruent to what angle matches up? What angle corresponds with angle A? E. Congruence. So angle A matches with angle E. So I put angle E first. Angle B matches with it, which angle? F. Angle C? G. And finally H. So this is my congruent statement. Angle A is congruent to angle E, B is congruent to F, C is congruent to G, D is congruent to H. A corresponds to E, B corresponds to F, and so on. And for the sides, side AB corresponds to side EF. Side BC corresponds to side FG, and so on. So the congruent statement tells us exactly how our polygons match up. And I could have named this polygon any other way that I'm allowed to name it. Start at any vertex, go clockwise, counterclockwise. And I could write a different congruent statement as long as I matched up the parts from the other polygon in the right order. So it's matching up the parts in order. Questions on that? All right. So this tells us how we match up our polygons, how we can, how we figure out if they're congruent. So this leads us to our postulate for this section. A polygon congruence postulate. So let's remember what did we say a postulate was? Something we believe or accept as true without proof. So this is the thing we're going to accept as true without proof, is that polygons are congruent if and only if we have two things. Corresponding angles are congruent, and our second thing that has to be true is that corresponding sides have to be congruent. So this is our postulate that tells us our shortcut really for deciding if polygons are congruent. Rather than having to say, okay, I can do a translation, a rotation, a reflection, and these two will match up exactly, what I can say is, are corresponding angles congruent and corresponding sides congruent? If that's the case, then those two shapes are going to match up exactly. So it's kind of our shortcut. And then for triangles, we'll work with triangles. Triangles have some even nicer shortcuts that are even shorter shortcuts that are nice to work with. So questions on our postulate. All right, let's look at a quick example using this postulate, and then we will be done. So let me draw a nice triangle here. And I'm going to draw this part right down the middle. So, and we'll call this triangle REX, and we'll call this point F, and I'm going to label up the points, label the parts of the triangles. Those are congruent. Those are congruent. I'll do the angles in blue. And the question here is triangle REX congruent to triangle FEX? That's our question. So we need to decide if corresponding angles are congruent and corresponding sides are congruent. So let's look at angles. What angle matches up with angle R? Angle R is congruent to angle F. So those are okay. Angle REX, this angle here, is congruent to which angle?
FEX.
Angle FEX. Angle RXE. So this angle down here is congruent to which angle on the other triangle? FXE. So we have our angles matching up. Now let's look at our sides. Segment RE. Segment RE is congruent to which segment on the other triangle? Segment EF or FE. How about segment RX? It's congruent to segment XF. And then finally, how about EX? EX is congruent to segment EX. Segments are congruent to themselves. So they share this middle piece. They're congruent to themselves. So we have corresponding angles are congruent. We have corresponding sides congruent. So our answer is yes. Woohoo! The triangles are congruent because the corresponding angles are congruent and the corresponding sides are congruent. Now, the nice thing when we work with triangles, we have some shortcuts so we don't have to check every single angle and every single side. But for polygons, we do have to check every angle and every side. All right, questions? Okay. Homework. All right, there you go.
Are they all
Just this last set are even.